So we'll start off with a little bit of geometry review. Let's say, for example, that we have parallel lines. Okay, let's pretend they're parallel. Let's do this. Make sure they're parallel. Come on. There. We actually have three parallel lines in this case. If I cut these lines with a transversal like that, if I were to tell you that this angle here is 124 degrees, what's this angle here? How much? 56. How do you know it's got to be 56? Yeah, we know a straight line's 180, so those two have to add up to 180. What's this one? 124. This one? 56. This one? 56. This one? 124. 56. 124. 56. You get the point here. No matter how many parallel lines they are, as long as they're all parallel to each other, that transversal is only going to form two angles anywhere as it cuts through those parallel lines. There's two more down here, but you guys get the picture. I don't need to label them. The other feature that we have on parallel lines, let's say I cut this with another transversal like this. Let's say I label this length here as 14 inches. And this length here is 8 inches. If this length turns out to be 6 inches, can I find this length? Well, yeah, because the angles here are all the same. Because this angle and this angle have to be the same. And this angle and this angle have to be the same. What can happen is, if I get a different color here and draw it out, I can take this side here and its base, this side here and its base. Those are going to be the same angle. If I pull them out like that, then I come over here and I have this side and this parallel line and the same here, this side and that parallel line. I can pull them out. You can see I can make a triangle out of it like this. There we have triangles. And from what we've seen already, we know, oops, come on, here's what I need. This angle and this angle are the same, and this angle and this angle are the same. So it means the third angle has to be the same. So those are similar triangles, aren't they? Which means this side relates to this side the same way this side relates to this side. So in other words, 14 relates to 8 in the same way that x relates to 6. So we can cross multiply and divide. 14 times 6 divided by 8 is 10.5. What do you think? Pretty cool? Yes? No? Nobody cares? Sweet? Sure. Now you can see in construction this comes up a lot. There's a lot of parallel lines. I mean, you look at your stud walls, those are parallel lines, multiple parallel lines. Floor joists, multiple parallel lines. And as you're measuring, what's that? Well, I mean, if you're doing a building, especially once you get windows and stuff in it, your studs aren't always evenly spaced. You might have a, wall where you've got your studs here, but now this next stud's a little bit closer because there's got to be a window here. Then this stud might be at an odd spacing and whatever. And when you go to angle brace this, by the way, now for some of the new codes, you have to have the built-in angle bracing, permanent angle bracing. The OSB sheeting is no longer adequate shear reinforcement for a wall. You have to have your sheets laying down like this. You got to glue the edges of them together, and all sorts of stuff that you've got to do in certain spots on the house. Scotty, I'm sure, will go over that with you at some point. It's new code. They don't even really know exactly where you have to do it yet, but it is new code. So let's say you've got an angle brace like that, then you got another angle brace that goes at a slightly different angle like this. If you need to know, how far, let's say you want to know how far it is going to be from here to here on that angle brace. Well, if you know this distance, and you know one of these other distances, maybe you know from here to here and here to here, you get parallel lines with two different transversals. The same thing's going to happen. Let's say I know that this here is 20 inches, and this over here is only 8 inches. Let's say I happen to know that this one up here is 9 inches, and I want to know this distance. Well, 20 compares to 8 is the same way that x compares to 9. If I cross multiply and divide, 20 times 9 is 180. Divided by 8 is 22.5. What's that? 18. Okay, so enough about our parallel lines and reviewing our transversals and stuff. Let's start looking at triangles and types of triangles. We can classify triangles in two ways. We either classify them by their sides or by their angles. By their sides are the way we're probably the most used to seeing triangles classified. If we have a triangle that has all three sides different sizes, we're used to just calling this a triangle. But when I mark it with 1 mark there, 2 marks there, and 3 marks there, that's saying that all three of those sides are different. If any two of the sides had the same number of marks, that would be indicating that they're the same. So this triangle has all three sides different. It's what they would refer to as a scalene triangle. I could have a triangle that's marked like this, where those two sides are the same and that third side is different. That's what is referred to as Isosceles Triangle. Or I could have a triangle where all three sides are exactly the same, which is called equilateral. So let's classify a triangle by its sides. Well, the other way you can classify triangles by its angles. I can have, we'll start out with a special one. I have a triangle with a right angle in it, which is called a right triangle. Yeah, right angle triangle, or right triangle. Notice that in that triangle, the right angle is the largest angle, because triangles have to add up to 180. If you have one angle that's 90, you can't have anything else that's bigger than 90, or you have to go over 180. So in a right triangle, that right angle is the largest angle. Because of that, our other triangles are named based on their largest angle as well. For example, I might have a triangle like this, where the largest angle is smaller than a right angle. So in other words, the largest angle is acute. That's called an acute triangle. I might have a triangle like this, where the largest angle is obtuse. That means we have an obtuse triangle. Looking good so far? Occasionally, there's combinations of those. Equilateral pretty much stands on its own. Not a whole lot you can do with equilateral. But you can have something like this. That is, not only is it a right triangle, but it's also an isosceles. You'd call that an isosceles right triangle. You might have something like this. That is what two types? It's acute, yep, and there's an isosceles acute triangle. And of course you could have this one, which is not everybody at once. Isosceles, and it is obtuse. Any questions so far? What I want to focus on next, then, is the isosceles and equilateral triangles. And mainly the isosceles triangles. Because an equilateral triangle is also an isosceles triangle, pretty much. Isosceles is any triangle that has two sides that are equal. So an equilateral triangle, bless you, an equilateral triangle, the third side happens to be equal as well, but it doesn't matter. It still fits all the rules. In an isosceles triangle, if you're looking at that angle that's between those two equal sides, one word that we're going to talk about is called an altitude. We mentioned this a little bit when we were talking about the area of triangles. The altitude is the distance from one of the vertices of the triangle to the opposite side. And of course, that's measured at a right angle. So a true altitude goes in there at a right angle. So let's say I do that. I drop this as an altitude, it goes down, makes a right angle with that opposite side, like that. But because this is an isosceles triangle, it does a lot of special things. First of all, in a triangle, in any triangle, if I label these sides here, A, B, and C, which side here is going to be the longest? C is obviously the longest. The relationship is the longest side is always opposite or across from the largest angle. So here, which of these two angles would be bigger? I call this A or B. What's that? They're exactly the same. Why? Their opposite sides are exactly the same. If one of them is bigger than the other, then this opposite side would have to be bigger than the other. But since those opposite sides are the same, the angles have to be the same. Because those angles are the same, and this is a 90-degree angle on both sides, guess what? This angle up here has to be the same. So what this altitude does is it divides this isosceles triangle into two congruent triangles, two equal triangles. So what does that mean? Well, that means that altitude cuts this side here in half. It's called a median. It cuts that opposite side in half. It's also what we call an angle bisector, because it cuts this angle here in half. These two angles are equal, and they're each equal to exactly half of the original angle. That gives us a lot of applications. For example, let's say you're working on a round piece of material. One of the common ways of working on a round piece of material is to put it in something called a V-block. That V-block kind of traps it in its spot and it doesn't allow it to roll away. If you want to do any calculations on that, though, if let's say you want to know how high the top of this ball, this rod or whatever round piece of stock sticks up from the top of your V-block, well, you can't figure that out based on just this angle down here. Let's say this angle here is 80 degrees. But what you can do is this. You can divide this up, and you can cut this in half, because this length and this length are going to be the same. If I draw in this line here, that cuts this angle into 40-degree angles, just like any other isosceles triangle. So anyway, now that we have those angles, hopefully we'll have the radius or whatever of our piece of round stock. We can then use our trig in a couple of weeks, once we start learning it, to find these dimensions. No, oh no. For right now, I am going to leave with those preliminaries in your book. Page 482 to 484. I think it's like 1 through 8 or something like that you can look through. those are just kind of more looking through and making sure you understand the vocabulary. Then on page 495, exercise 22-5. There's just 1 through 6. This should be a short one for you today.